So what if a data center wasn't some huge static building, but a fleet of trucks? Today we're going to dig into this pretty wild blueprint for the future of cloud computing. It's a concept called the G2 Container Data Center Unit, or CDCU. Basically, an entire data center ready to go on demand.
All right, so everything we're about to talk about, it all comes from this one single hand-drawn diagram. Now, I know it might look like just a sketch, but trust me, it lays out a really radical vision. It completely challenges our whole idea of a data center as this fixed, massive building and asks, what if it could be mobile?
You know, we're all used to the idea of the cloud being this huge, abstract thing somewhere far away, right? But this blueprint flips that whole idea on its head. It asks, what if, instead of you going to the cloud could actually come to you? What if you could just dispatch a data center and have it show up right at your location exactly when you need it?
And that brings us right to the heart of the concept. Data centers on wheels. Yeah, you heard that right. It's a total rethinking of how we use and get access to high-performance computing. We're talking about moving from a static, rigid model to something way more flexible and, well, dynamic.
So the main building block of this whole system is the CDCU, the Container Data Center Unit. And really, the name tells you everything you need to know. It is an entire self-contained data center that's been packed into a standard shipping container. And using that universal format, that's the genius of it. It makes it instantly modular, scalable, and most importantly, super easy to move around.
And here's exactly how it gets that mobility. The diagram calls this a truck-mounted node. But this isn't just about throwing a box of servers on a flatbed truck. No, the diagram specifically calls it self-sustaining. And that is a huge deal. It means it's designed to run completely on its own, anywhere that a truck can get to.
But here's where it gets really clever. This system isn't just about being mobile, it's also about having this dual nature. The whole concept is built on two totally distinct ways of operating. One as a quick, independent mobile node, and the other as part of a powerful, stationary grid. Okay, let's take a closer look at that mobile node. So, it's on a truck, obviously, for quick deployment. It's self-sustaining, so it's got its own power source. For cooling, the diagram points to either wind or a standard air conditioner. You know, simple, adaptable stuff that works great for a standalone unit. And to connect to the network, it just uses Wi-Fi. Super flexible, no matter where it's parked.
So you might be wondering, where do these trucks go when they're not out on a job? Well, they come back to a home base. And the diagram calls this the on-premises grid. All the individual trucks line up in what looks like a parking lot, and together they become something much, much bigger. A really powerful, consolidated data center.
And it's in this grid mode that the system's true power just gets amplified. You've got multiple CDUs all working together, creating this incredible high-density compute cluster. And here's the kicker. They ditch the flexible Wi-Fi and plug directly into a hardwired network fiber grid. This gives them blazing fast speeds between all the units, turning a parking lot full of trucks into essentially a single cohesive supercomputer.
So let's just put these two modes side by side for a second. The truck is all about rapid response. It's self-powered and connects over Wi-Fi. The grid, on the other hand, is for massive, scalable infrastructure. It plugs into the main power grid and a high-speed fiber network. Now, what's interesting is the diagram doesn't specify the cooling for the grid. But you have to imagine, with that kind of compute density, you're going to need something a lot more serious than a simple AC unit. This is a truly hybrid approach to computing.
Okay, so we've seen how these units operate on the outside. But now let's take a look inside, at the one component that really makes this whole thing possible, the power core inside the CDCU itself.
If you look closely at the diagram, you'll see a few different ways these containers could be configured inside, from a few PCs to full-on server racks. But notice the one thing that's there every single time, in every configuration? These integrated battery modules.
And look, we're not just talking about some little backup battery here. No way. The diagram is very specific about this. A mobile unit can run entirely on its own battery power for up to 6 hours. Just think about that for a second. That isn't just mobility, that's true autonomy. It unlocks the ability to deploy some serious off-grid computing power for a really meaningful amount of time.
So this is the crucial takeaway right here. The batteries are everything. They are what truly make a CDCU self-sustaining. They completely sever the cord to a fixed power grid. That lets you send one of these units to a disaster site, a remote movie set, or a temporary research station, and it just works.
So when you combine the mobile units, the home-based grid, and that all-important battery power, you don't just have a new piece of hardware. What you have is a revolutionary new service model.
The blueprint is essentially describing an Uber for data centers, an entire fleet of computing power just waiting to be hailed at a moment's notice.
And the workflow is just so simple and elegant. A need comes up, a request is made. A self-sustaining CDCU is driven out to the location. It does its job for up to 6 hours totally off-grid, and then it just drives back to the central parking lot to reconnect to that fiber network and, this is key, recharge for its next mission.
So in the end, this whole concept is really asking us to stop thinking about a data center as just a single product or a place. It's a system. It's a living, breathing network of mobile compute power that is just fundamentally more responsive and resilient than our traditional centralized model could ever be.
So what's the big idea here? Well, the cloud has already virtualized our servers, our storage, our networks. This simple blueprint suggests that the next logical step is to virtualize the data center's location itself. This isn't just about putting data centers on wheels. It's about a future where infrastructure isn't defined by a place anymore, but by a need. Pretty cool, huh?